All right, well, welcome back to afternoon session. Our next speaker is Jeff Sly, who is the system architect behind the monitoring implementation at Nu Skin Enterprises, and it is a $1.6 billion company that spans 53 countries. And at Nu Skin, they had the unique challenge of consolidating multiple monitoring platforms across their worldwide data centers. So Jeff's going to talk about their experience with that. Let's give Jeff a hand.
There we go. This is a great conference, and Nagios is a great product. We love it. We're thankful to work with the Nagios team. Let's see if this works. So who's in the audience? I just wanted to understand a little bit, how many of you are currently using Nagios in production, by show of hands? Okay. How many are looking to expand or increase your Nagios installation or set up a new installation for the first time? All right, and how many are using Nagios XI versus Nagios Core? Nagios XI, 1, 2, 3, 4, and Nagios Core, and who doesn't know what they're using? Well, thank you. That just helps me a little bit. A little bit about Nu Skin. Nu Skin is a direct selling organization. We sell products, lotions, cosmetics. Your wife probably has heard of the cosmetics side. It's kind of an upscale Avon kind of a thing. Also vitamins and supplements. Later this month we'll have a conference in Salt Lake City with 13,000 distributors at it. So anyway, that's a little bit about Nu Skin. Our technology footprint at Nu Skin consisted, as we began this case study, we have a homegrown e-commerce system. We started e-commerce in 1996. So we've been doing online web ordering since 96, and there wasn't really much out there at that time. Most of our stuff today is based on Java and Oracle, but we do have .NET and MySQL and Microsoft SQL and Windows and Sun and HP Unix and all kinds of other stuff. We've got data centers in 6 countries and offices in 50. We actually do business in, I think, 53 countries. Our monitoring goals are probably pretty similar to your monitoring goals if we get at a high enough level. Monitoring was supposed to present our operations with a completely global integrated view of what was going on all our systems. And if something was down or out, they were supposed to know. Good monitoring is proactive. It helps teams prevent problems before they become an outage instead of just saying, hey, the system is now down. And good monitoring helps minimize outage time so that we quickly identify the root cause of an outage, not just these 5 things are not working, but this is the one that causes these 5 things to not work. So we wanted a centralized monitoring system. This is not ours. This is just some nice picture I found. We tried for 10 years, and our monitoring history was a failure, and most of it was a failure because we got distracted. We would start with these big, grandiose ideas, and we would lose our sponsorship, or the project would go over, or some guy would quit, or whatever else. And so then the new guys and the new team would come in and be tasked with setting up monitoring, and they would work on it for a couple of years, and then they would go somewhere else, or somebody would cut the funding. And at the end of 10 years, we wound up with 17 different ways of doing monitoring, 10 different major packages that we had that we were using for monitoring, and lots of Unix guys and other guys writing their own scripts and paging themselves with their own scripts because monitoring stuff never worked. And we actually had a pretty good track record of keeping our systems up, but monitoring was a mess. It really was pretty scattered around. Our our strategy had been one monitoring tool to rule them all. And so we tried to go out and shop for, we're going to use Mercury SiteScope, or we're going to use HP OpenView, and we're going to come in with this one tool, and we're going to set up all of our monitoring on all of our systems and all of our countries in this one tool. That was our strategy, and that ultimately failed every time. We could not get everything into one tool, and it was just such a cumbersome big effort that it always ran out of gas. The latest one that we tried was multiple hundreds of thousands of dollars we were going to spend for fog light licenses with Quest, and we actually paid for consultants to come out, and we implemented. And at the end of the year, we finally had the system all put together to do the monitoring, and we started trying to add the monitoring stuff in there, and performance was bad. We had to, we went to the Quest guys, and they said, well, you need to do an upgrade. And we said, well, we just spent a year setting this all up. I said, yeah, you need to spend another year doing an upgrade. And we'll bring out, 4 weeks of consultants and do all of this. And we said, wait a minute, this is a little bit hard. And there was a lot of chat on the network, a lot of CPU utilization on the servers when we put their clients out there, and we could only monitor what their clients had been programmed to monitor. It was a closed system. And the same thing was true with Mercury SiteScope. Basically, what they had determined you could monitor is what you could monitor, and that was it. It was pretty hard to do much else. And so we had lots of homegrown things that we did. We basically had a monitoring team that consisted of one person that was trying to accomplish this with each of these packages. And the last time before I got involved as an architect, the monitoring guy quit. Said, I got another job at another company. And so we stepped back and decided we were going to do a little planning, a little looking at it, and decide what we wanted to do instead of just saying, hey, we've got this system guy and we're going to throw some monitoring software at him and tell him to set up monitoring. I've talked about a lot of this stuff, but the proprietary tools that are out there have a huge learning curve and a big footprint. People that were successful with these other big tools typically had teams of 4 or 5 people working full-time on monitoring, and lots of servers and lots of money spent on monitoring. And we just didn't really see ourselves willing to commit that much. And the upgrades were very, very difficult and very expensive. And the system administrators, when I asked them about replacing monitoring with a new tool, they said, well, you can do what you want. We're going to keep doing our scripts that page us, and we know they work. And we don't really want to have, some black box that's going to take a lot of resources. We also had tried to make an operations team the clearinghouse for all warnings and alerts. The idea was that the centralized view of everything meant every alert, every warning, and every informational piece had to go to this team, and then they were supposed to parse through that and determine what was important and who needed to be contacted and contact them. And can you see how that might cause some problems? They were overwhelmed. There was thousands of pieces of information and warnings that just from our Oracle database systems alone, we generated 10,000 pieces of information in a week. And how can you take a junior help desk guy and train him how to parse through that and decide which things need to be, calling a DBA at 3 o'clock in the morning, and which things, if you call the DBA at 3 o'clock in the morning, he's going to yell at you and scream at you for what'd you call me for that for? And a couple of times of doing that, and they're pretty hesitant to call somebody at 3 in the morning. So we looked at our strategy and decided, something's got to give. At the start of our project, our users were a little bit unhappy. They were complaining that customers were calling our call center and telling us about our systems being down instead of monitoring telling us our systems were down. Now, if you remember, our goal was to find out about an outage before it actually became an outage and fix it before it became an outage, but we were not successful at that. So we had In our old monitoring workflow, as we analyzed that, there was 4 steps that it took to notify an administrator. The first thing was that all of these different monitoring tools, I don't know if you can read that or not, the HP OpenView, we had an old version of Nagios, SiteScope, BACs, another version of SiteScope, FogLight. We had Oracle Enterprise Manager and other database tools. We had system scripts. We had the network guys had 3 or 4 ways of monitoring things. Everything was supposed to email one inbox. And then they were supposed to parse through that one inbox and figure out what was critical, what was warnings, who needed to be contacted. So the operations guys opens the email, and that's a separate step because that didn't happen automatically. And then the operations guys tries to make a determination of, where did this come from and is it critical? And then the operations guys calls the admin. So that's the 4 steps that was happening before when it happened. So the next thing we did is we sat back in kind of a planning mode and we did an inventory of what are all of the things that all of these different systems are checking alerts on. And I kind of want to go through this quickly on this version of the slides because later on I repeat the same inventory and tell you what our solution was for each of these, which ones we could use out of the box Nagios, which ones we could use a custom solution for that integrated with Nagios. So I'll come back to this inventory later in the presentation. And here's some more of the inventory. So these are all the kinds of things that we were trying to monitor with all of those different packages. So our to-be was we wanted happy customers, and our happy customers were not just outside of the company, but the business units inside of our company. And these are the key ideas or breakthroughs that allowed us to become successful. And I'm going to talk about each one of these 5. MOM, the tool requirements, the shared ownership, the lowest level, and the Nagios monitoring method selection. So the first idea, MOM, or the breakthrough was that we needed a centralized view for all of our monitoring, but that did not mean we needed one ring to rule them all, or one tool to rule them all. What that meant is a centralized view could be a hybrid of several things that came together into one place. And so we backed off from the goal of one piece of software that was going to do all of our monitoring to the goal is all of our monitoring information is going to come to one place. That was one of our first key pieces. And a big piece of that was Oracle Enterprise Manager is really good at monitoring all kinds of database-specific things. SAP's Title Monitor, it's a third-party package for the SAP system, is really good at monitoring stuff in there. And for us to try and reinvent the wheel in those areas was not productive. Instead, we needed to integrate with those tools and pull that into our dashboard or our single view of the world. So according to Gartner actually termed this phrase manager of the managers. That's what MOM stands for, is manager of the managers. I don't know if you can see this very good or not, but what they represent here is with the yellow and the orange and the blue is different monitoring systems that are feeding information to this kind of an umbrella overarching monitor view. And for us, that umbrella became Nagios. Nagios became the umbrella, and another goal that we had was to consolidate 7 of the 17 monitoring platforms that we had into just Nagios down underneath feeding the umbrella. So it was the umbrella, and it also represented 7 of the tools feeding the umbrella. That's what we chose Nagios for. So it didn't replace everything, but that's kind of what our goal is. And I have to give credit to Gartner for this slide. So our requirements, when we rethought about what our requirements were and redefined our strategy, was that we wanted open. That did not necessarily mean open source, although we like open source, but it did mean couldn't go like Foglight, where it was a black box, it was a client, and it could only do what the black box did. We wanted to be able to extend, stretch, customize, and interface to other pieces. So that's what open means for us. We actually use the commercial version of Nagios, not the open source version, but it's still open. Mainstream, we wanted a good, strong community with good support. We wanted to be able to interface to third-party monitoring tools. We wanted to be flexible, efficient. Efficiency was do or die for us. If the tool required a client that took a lot of CPU resources on the server, or if the tool did a lot of chat across the network, then it wasn't an option no matter how good it was. So that was kind of a do or die for us. We wanted granular control over the notification, and I'll come back to why that's important and how we use that. Reliable, obviously. And another piece was the usability. We needed a GUI interface for most of the elements because of some other ideas or breakthroughs that we had. And I'll come back to why the GUI interface was important, but it had a lot to do with the sharing of the ownership. Remember, we had one guy that was trying to do monitoring. The number of new servers that we set up each month and the number of new monitors that we needed was more than he could set up just doing that full time, but he was spending all his time just trying to keep the monitoring environment up. He had no cycles to go and set up alerts. So shared ownership is the third major idea. So we have a core monitoring team, and the core monitoring team is responsible for the operation of the monitoring environment. Nate, you want to wave your hand? Nate is the lead of that core monitoring team, and he's full-time on monitoring. He makes sure that all of the upgrades of Nagios happen smoothly, the backups happen smoothly, and any new technology or new plugins or new other kinds of things, he works out all the details on that, builds the how-to guides, and shows other people and teaches other people how to do their monitoring. So then we have monitoring experts in each of the groups or in each of the teams, and they are the ones that are accountable, not the monitoring team, if their system is not being monitored. So if your system goes down and a monitor doesn't fire off, it's not the monitoring team's fault. If it's the database team, it's the database team's fault. If it's the HP Unix guys, it's the HP Unix guys' fault, and on and on and on. The Windows guys or whoever. And this was key because this allowed us to set up over 3,000 monitors in about 6 months' time, where before, with one guy, we could nowhere come close to that. And the monitors that they set up were the ones that they wanted, and they notified them. They determined what was critical. Can you imagine the one help desk guy trying to figure out what's critical on each of the systems versus a monitoring lead in each team? And all we have to do for the core team is just train them. And we've had to train them twice. The first time we trained them all and told them it was their responsibility, and they said yeah, and they set up a couple monitors, and then they didn't do it. And you would experience the same thing if you tried to share ownership. It doesn't happen first the right way. And then some of their systems died, and the monitors didn't go off, and their director came to us and said, hey, you guys are failing as the monitoring team. And we said, no. Remember when we talked about, and we had this in writing, the presentations that we gave them. We didn't sign their name, but we had the presentations. We said, you guys are responsible for this. And they said, oh. So then the director goes back to all the managers in his group. And the same thing with the application teams. All the web development teams and all the others, their managers were accountable to set up all the monitoring, all their applications. So this really affected the quality of our monitoring. Instead of it's just up or down, to now we can tell you it's too slow for the customers. And we need to speed it back up, or the service is not where it should be. So now that operations owns their own monitoring, the flow now is I don't like that slide. I like this one. Before it was this mess. that we had going on with the 4 steps. And now the accountability is in each of those groups: the network, the database, web, SAP, Europe, Asia. And in order for them to be successful, they kept saying, oh, we don't know how to set up monitoring. We had to set up how-to guides. And so this is an example of a how-to guide. Here's a list of some of the how-to guides that we set up. You probably can't read that, so I'll read a couple. How to set up a Nagios user, how to set up a host, how to set up a service, how to add an NRPE service to an HP Unix box, how to set up a configuration manager user, how to set up a contact group, how to set up a host group. And we actually went through flowcharts, step-by-step instructions, and screenshots. Here's kind of some of the details on how to set up NRPE on Unix, which is Nagios Remote Process Execution. And that saves our bacon because it allows us to extend the reach and the processing power of a single Nagios instance, because we offload a lot of that processing to the boxes that are checking themselves. Idea number 4 was the lowest level. And what we mean by that is, instead of forwarding all of the alerts up to the help desk guy and having him sort through what needed to be handled and try and communicate that back, if the DBA guys needed to know they were running low on disk space in one of their tables, then that alert would go to that DBA that needed to add the space, and he would fix it, and the help desk would never be in that cycle. And that is a key idea. So the amount of information that trickles up to the top level now is just the things that actually crashed. 95% of all of the alerts never go to the top level because they are sent, acted upon, and fixed before they become critical. And so the information flow and the design on that information flow is really important. I've heard several people here at breakfast and lunch talk about, parsing log files for when the system goes down. And for us, we have a hierarchy of services. At the highest level is the end user customer outside the company who wants to be able to place an order on the website. And underneath that, there are web servers and application servers and database servers that are all providing services to each of their customers. So the database server is providing query results to the app server is providing, the middleware server is providing services and APIs to the web pages. And each of those services, we went through and kind of did a key evaluation of what had broken in the past, where had we been burned before, and we set up monitors of each of those services. So at the top level, we go through the web page and we actually simulate the process that the customer goes through. We log in, we add products to the cart, we go to the checkout page, and we place an order. And we time how long that takes and if every step of that is successful. And if that's not successful, then we're also monitoring the pieces underneath that, the key pieces. Now there's thousands of pieces we could monitor, but we don't do all of that, just the key pieces. Were we able to make this service call to do this inventory check? Were we able to make this service call to save the order? And if saving the order fails or takes too long, it's taking 13 seconds instead of 1 second to save an order, then we alarm that. Does that make sense? And so for us, we have a pretty good picture of what's going on in the company. It's not complete yet. We're not done with all we want to do. But it's not about, are the servers up or the servers down? Because we used to have system guys tell us, well, the server never went down. And the customer says, yeah, but it was 5 minutes trying to save an order, which to the customer, it doesn't matter that your server's still up. They've given up on the web page after 5 minutes. So handling the events at the lowest level, and this is kind of a graphic to that. So these little red lines down here just show the individual teams getting the alerts instead of it all going to operations. That frees up operations to only have to work on the most critical stuff. And so if we have a really bad outage, they're not buried in all of this other stuff that they're handling that's, kind of warning conditions. They can really handle that. And we only forward the most critical stuff to them. idea number 5 is Nagios monitoring methods. And I've heard several talks already today talk about all of these concepts or ideas, but none of them explain it very well as far as the differences between them. And I'm going to make an attempt at it. I don't know if I'm going to be successful or not. But there are lots of ways to accomplish monitoring. And sometimes I've heard this talked about as distributed Nagios monitoring. Sometimes it's these different terms. But really, if I just step back for a minute, ignore the slide for a minute, you can monitor from Nagios locally from the server and do an active check. You can monitor from Nagios and do an active check that happens remotely. You can monitor from Nagios and do a passive check, which means Nagios is just listening, something else is doing the check and reporting it back. If you can get just that much, then that's significant. So let me try and go through that and reinforce that idea. So an active local check means that the Nagios server is scheduled the check, and the operation of doing the check, like pinging a server, happens from the Nagios server. Or checking this web page, the Nagios server kicks off a process and goes out there and tries to hit that web page. As you get lots and lots of checks, if the checks are very processor intensive, then the Nagios server gets overwhelmed. Okay? But if they're simple checks, we do all of our pings, I think, from the Nagios server, right? But most of our more process-intensive operations, we do not perform from the Nagios server. So the second thing is an active check. So the scheduling of the event happens on the Nagios server. But the operation of doing the check is actually offloaded. And I've tried to represent down here on this Unix box a little piece of code that's the Nagios remote process execution code that exists down there on that box. So he just receives a message from the Nagios server that says, go and do this check and then report back to me what the results are. And that check may do 3 or 4 things and say, yeah, I'm happy with the result of those 3 or 4 things, so I'm good, or I'm a little bit slow, or whatever it is. So again, the scheduling of that check happens on the Nagios server, but it's performed remotely. And that can happen with NRPE on Linux, or with the NS client on Windows, or there's some new stuff that these guys are working on too that's kind of the replacement for NS client, as I understand it. I think there's also an NRPE for Windows coming out. And then the third way is a passive check. Remember I talked about that Oracle had Oracle monitoring that was really good about checking thousands of things in a database. Well, we want it to go out there and monitor, so I've tried to represent that. See if I can get the laser to work on this. So here is the Oracle monitoring box checking 1,000 different things on the database, and it's paging the database administrators itself on warning kinds of things. But if something critical is happening that's either the database is down or it's about to go down, then it's going to send a message to Nagios, and Nagios is passively listening for that message. And this is where we get our central picture, even though we're allowing monitoring to happen on another monitoring system. So the central picture doesn't happen for all of the things that could be handled down here in kind of a warning state before it became critical. But for the critical stuff, it does flow back up into Nagios. Any questions on this? This is an important set of pieces to understand. And then, this isn't really a 6th idea, but I guess it kind of is. After listening to some of the talks and talking to some of you, I decided to mention how important tuning was. You need to tune the databases. As they come straight from Nagios, they are not tuned. You've got to go in there and turn on caching and turn on some other things. You need to add a RAM drive. Every installation of Nagios Core, Nagios XI should be using a RAM drive to alleviate IOs. How much you choose to put on that RAM drive is up to you, but it doesn't need to be very big. So this is the kind of things that you need to do as far as tuning the database. And I'll just make mention that there's a website, and this will be in your slides. And underneath that, there's a section on Microsoft SQL tuning, and there's also a section on tuning Nagios. And just simple things. You just go into the one configuration file for MySQL and set these settings. This is just a getting started set of settings. You could increase them. But for example, this query cache size is turned off normally. By turning that on, our Microsoft SQL database is getting 80% cache hits. So 80% of the queries never go out through the Microsoft SQL engine and hit the disk. They're just cached. 80% of the queries. That, takes a lot of the load off of the server. RAM drive is the same kind of thing. If you put, we put all of these objects in the Nagios config file. We put all of these objects out there on the RAM drive, including the whole temp file path. And all of those objects are on the RAM drive, and none of that hits the disk subsystem anymore. And Nate is going to go into more details on a lot of the stuff, the technical stuff that we did in a presentation tomorrow at 3 o'clock. So I'm kind of the high-level guy, and he's the nuts and bolts guy. Another thing that we did was our methodology of implementing our project. And the methodology broke down into these steps. We did the site survey, or the inventory that we talked about, kind of looked at what we had. Then we did a proof of concept, where we actually set up a box and we tried some of the most important monitors. We tried, I think, about 20 different kinds or categories of monitors, and tried to identify how we were going to be able to monitor those. And then we started, we built a version of that environment that we thought was production worthy with backups and that kind of stuff, and started migrating monitors one product at a time off of the old product onto the new product, and adding missing monitors, the ones that were causing the business to beat us over the head and say, how come you're not catching this stuff? And then integrating to the other third-party packages and doing the passive listening. And since this slide's been put together, we've also gone and pushed this out to the other data centers and gone global. So another thing about our 3 project phases that we broke this down into is we had to do it in bite-sized pieces. We didn't want to repeat the history where we tried this huge project and didn't get done, and at the end we were left worse off than if we'd ever started it, because now we just have another unimplemented, incomplete monitoring solution. So we broke it up into pieces. I mentioned a couple of the key pieces. I don't know if you can read this, but setting up the pilot of Nagios. We also tried to do a pilot with Foglight to monitor stuff inside of the Java virtual machines at the application level, what was going on with memory usage in the Java machines and threads and other kinds of things. And we actually customized using JMX a solution that allowed us in Nagios to pull all of the same stuff that Foglight's client could. So we have access to all of the pieces down inside the Java virtual machine, every piece that's available. Another key piece was documentation. So if we wanted other people to own monitoring, we had to set up a website and put these how-to guides up there, and also the learnings and other information, and communicate a lot more openly than just a closed little monitoring team off in a closet somewhere. It's important to have somebody that's over project management, because otherwise you get down in the heads down mode, just kind of in the nuts and bolts, and it's hard to keep the perspective of, yeah, we really do have to go back and document that, or we really do have to test that, or we really do have to make sure this is production worthy, and communicate with the other teams. If it's not a task to communicate with the other teams and train the other teams, you'll never do it, and you'll wind up owning all the stuff that they should be doing. Phase 2 is where we actually, at the end of phase 1, we were in production. Phase 2 is when we migrated the things over. And phase 3 was where we really took it global, and that's where we started expanding into the other monitoring systems that we didn't replace, but we just integrated with. Some enhancements that we're doing. One of the other things that I'll just mention that was key for us is if you want to get buy-in from top management, they won't buy into stuff that isn't pretty for very long. If you don't have some graphs or something visual or something with a GUI that they can see, then they kind of lose interest in this monitoring stuff. And so we actually gave attention and service to some of this stuff. In fact, at our last quarterly business review, the one thing that IT was known for is when the distributors come through on a tour of our IT systems and of our high-rise building, one of the things they really like is our monitoring screens and our monitoring maps. So we spent some time making stuff pretty, and I'll show you this in a second. And that's one of the things the distributors come away from a tour of our company with, is we really like the monitoring stuff. And that's mentioned to the executives, and then the executives come down, and that gives us the energy that we need to enforce monitoring to happen in the different groups, if that makes sense. So it might seem like fluffy bunny stuff, but that fluffy bunny stuff is important. Let's skip that one. Okay, I promised you I'd go through this inventory of monitoring checks and how we did it. So just checking a web page to see that something is found on the page, some string is found on the page. We had about 50 of those, and we just used out of the box the HTTP check plugin or wizard from Nagios XI. The up or down check, again, that's just straight out of the box. The ping checks, that's just straight out of the box. Port monitoring, just the TCP/IP port. Is that a plug-in or is that a wizard? It's a plug-in. And the same with the FTP and SNMP, SMTP. The SNMP, because the MIB definitions change every time a vendor does an upgrade on their product, and because it's a pain to get the MIB definitions all set up, we were all excited about using SNMP everywhere, but in practice we found that to be similar to the pains that we had with other upgrades of other products, and we didn't really like that. And we found that we could go monitor most of the things that we were interested in this hierarchy of services without going to the SNMP level. And so simple network monitoring protocol is anything but simple, as somebody else said earlier today. I can't remember who it was. And we just are really kind of turned off on it. So we're doing some radius monitoring, DNS. For disk space monitoring, on Windows, we use the NS client that does the remote check, and on Linux, we use the NRPE, and that's just a Nagios disk plug-in. CPU stuff, Nate actually wrote a custom plug-in for us that actually goes out both on Linux and on HP Unix and pulls the same statistics. If you type in top and you see those statistics, it basically uses the same code that top uses and reports back those numbers in the plug-in to us. And if time is right and priorities are right, we might contribute that back to the group. There's no reason other than just priority and resources that we haven't. We're not trying to be secretive about it, but it allows us to do about 5 or 6 checks on all our Linux and HP systems. Isn't that right? Something like that. So Nate, when you run out of things to do and you're bored, some more things that we do, the memory monitoring is the same kind of thing, that custom stuff that Nate did for us, but it's just a plug-in that we use with Nagios. Service monitoring, A lot of times that's shell scripts. The transaction monitoring, where I talked about us logging in, placing an order as a distributor, we're using Selenium to do all of that. And Nate's going to give maybe a live demo or a canned demo tomorrow. Live demo if it works, and a canned demo if it doesn't. So that'll be exciting. And then we also use Mechanize for some of the simpler stuff. The web inject stuff that came with Nagios didn't really cut it for us. So these are the two pieces that we use when we're going out to a website and doing complicated series of multiple page things strung together. The JMX stuff, we have a guy in our team that went out and wrote a plugin that interfaces to JMX, and we basically are allowed to call into any of the elements that Java has. There's I think 10,000 different things we can check about the Java runtime environment, plus all of the stuff that's exposed through our applications. Anyway, on the email, I guess we check that we can send and receive an email and that it delivers it okay. This is what Nagios XI looks like, and you're going to see that, I think, when Ethan shows you. But one of the things that's good is when we go out and have these monitoring leads go and set up a new system, they go in here and run one of these monitoring wizards or enter the core configuration GUI, and these are what the monitoring wizards look like. So if they want to monitor a website, they click the button and go through the screens and click on a couple of buttons, and then 2 screens later they're monitoring the website. That's a lot different than Nagios Core, where you go in and edit core, you know, the text configuration files or use some tool to try and manage those. So this allowed us to share the ownership of the monitoring. Does that make sense? I mean, you could put a how-to guide together that showed them step by step how to edit each character in the text files, but your enforcement of that is probably going to be hard. And this is one of the screens in Nagios XI just to show you, you know, so it's showing how many high-rise network equipment, 38 systems are up. Over here we see one's critical, one warning. We found this screen not to be productive for our operations or help desk. They don't care what's up. They don't care about thousands of monitors that we're doing that are up. They only care about what's down. And so we came up with a screen like this. I don't know if you can see that or not, but by region, so here's US and Canada, Latin America, Korea, Japan, Southeast Asia, we show how many hosts and how many services we're monitoring, how many are critical that are not acknowledged, and how many are critical that have been acknowledged. And over here's the grand total, so there's nothing critical that's not acknowledged and acknowledged. This yellow does not mean warning. Remember, we're not sending to the help desk. We're not sending to the help desk the warnings. We're only sending to the help desk the criticals, and the flow is that they have to acknowledge that they've seen the critical, put their name next to that they've acknowledged it, and they're trying to contact the person responsible. And there's an escalation for that. So if one of these, like this region right here, has a problem and you click on it and drill down, it will show you the details and what cities in that region. So we'd get something like this if we had an alert. We'd see in this US and Canada, we have 3 unacknowledged alerts and 35 that are acknowledged, and then we get details. We originally wrote this stuff to use the Nagios APIs, but it was taking us 12 to 13 seconds to come back with the results that we wanted from the Nagios API, so we scrapped that and wrote database queries to directly hit the database and pull back the information we wanted in about, I think it was about 100 milliseconds, so about 1/10 of a second instead of 13 seconds. And so one of the things that we've talked to Mike and some of the others about is if we supply them some of our queries, they can publish those queries and expand the API set. And because the existing API shows it returns everything about every alert check in your system. So if you want to find out whether this particular system is up or down, you call the API and it gives you the information for all of the alert checks in the whole system. and you have to wait for that whole thing in the API today. We wanted just the ones that were not acknowledged and the ones that were acknowledged, and we just wanted a lot more details. And so we wrote our own stuff directly off of the database. IT operations has a little bit different view of monitoring than others do. They want to know about stuff and recover from it. And the programming teams have this view. I'm going to kind of skip through that. So in summary, our breakthroughs were the manager of the managers, the tool requirements and adjusting those, having a shared ownership, handling the alerts at the lowest level in the organization, and choosing the right Nagios monitoring method, whether it was active local, active remote, or passive, to integrate. Tomorrow, Nate's going to have a presentation where he goes through some demos, talks about some of our performance challenges and solutions, and how we migrated off of some of this stuff, and some of the customization, and some other things. So that's tomorrow at 2 o'clock, is that right? Okay. So are there any questions?
I'm curious to understand, so distributing the work and ownership of the monitors is great. Do you have anything in place for like a code review and sort of benchmarking? Because we actually had one case where a monitor was actually degrading and bringing a service down. And so, you know, we think it's a great idea, but how do you sort of know that everybody on the end is writing good monitors?
We typically write the monitors in the monitoring team ourselves and have them supplied as a canned unit and tell them go and replicate what we've shown you how to do on your servers. So that's kind of what Nate does, is he goes through and writes all the custom plugins in the monitoring team himself, or works with the other group. So we have our hands in that pie, and then once it's developed and rock solid and tested on the test environment, and we do make them test it on the test environment first, then they go and put it on all the boxes that need it. Does that make sense? Does that answer your question? Not exactly. We work with them. If they've got something that they're doing, we don't let them just go loose. We kind of babysit it. Any other questions? I bored you all to tears, huh?
All right, well, let's give Jeff a hand.